All right, welcome back, everybody. We've been talking about factoring for the last couple of days. Today, we're going to get into some special factoring cases, but we're also going to review the process a little bit. So, in 8-24, we're given a problem over here that just is asking us to factor. Now, remember, when we factor, we want to write this as an area of or as a product of the areas. So coming over here, the way we're going to handle this is we're first going to look at this and we're going to notice that there is not a number in front here. So we're going to put a 1 in front to hold that spot. Now remember, when we factor, we want to use our x over here, do a diamond problem, and we're going to multiply 1 times 9, and that's going to give us the number on top. Now, whatever number's in the middle here, that's the number that's going to go on the bottom. And then on the side over here, we're going to make our fractions. And then, just like we did yesterday, we're going to pretend this little 2 is not there. And we're going to write whatever that first term is, 1x over and 1x over. Now, as we go on, remember, what we're always looking for is we're looking for numbers that multiply to be the top, that add to be the bottom. Now, hopefully, this one's a pretty basic one. I'm hoping that you can see this right away, that 3 times 3 is equal to 9, and 3 plus 3 is equal to 6, so those are in fact the two numbers we're looking for. Now in this situation, before we do anything else, our last step, we always need to look at our two fractions and make sure they can't be reduced. And in this situation, they can't, since there's a 1 on top. Remember, if there's a 1 on top, they're not going to be able to be reduced. So we can draw our two sets of parentheses, and remember this is a positive 3 and a positive 3, so we'd be able to write this as 1x plus 3 and 1x plus 3. And just like that, we are all done with this problem. Now let's look at problem number 2 here. Let's do another one. So on this one, we can see that we have the number out front. So we want to take that 2 and multiply it by this 3. And that's going to form the number that goes on top of our x here. So 2 times 3, that's going to give us 6. On the bottom, we're going to put 5. We want to make our two fractions on the side. Remember, it's multiply to the top, add to the bottom. Now I want you to think for a second, what should go on top of our fractions? Remember, it's whatever is right here without paying any attention to the squared. So this is going to be 2x over and 2x over. Now, we need to find two numbers that multiply to give us a 6, that add to give us a 5. Hopefully, we know that that would be a positive 2 and a positive 3. Since those are positives, I'm going to put the plus in front. Now remember, before we go any further and write down our factors, we have to make this very important check of reducing. So look at the 2 and the 2. We know 2 goes into 2 once, and 2 goes into 2 once, so that we can reduce each of those. On the other side, we have 2x and 3, and the only number that goes into both of those is 1, so those ones can't be reduced. Meaning our final answer will be 1x plus 1, and then 2x plus 3. And just like that, we have the factored form of that quadratic expression. Let's go on over here to part C. Looking at part C, there's no number in front, so we can put a 1 there. So we're going to make our giant x, multiply to the top, add to be the bottom, make our fractions. So we're going to have 1 times negative 7, that's going to go on top. Positive 5 is going to go on the bottom. Now we know we're going to have 1x over and 1x over. Now this is where we need to think. What numbers multiply to give us a negative 7? Well, the only numbers that multiply to give us 7, let alone negative 7, would be a 1 and a 7. And there's no way to make this work so that they add to give us a 5. So this is actually a really unique situation, because since there's no way to make the x work, that means that this is not factorable. Not every expression is able to be factorable. And when we run into them, that's okay to say that, but we got to be really sure that that's the case. So again, why wasn't this factorable? Because we couldn't find, so we could not find two numbers that multiply to negative 7 and add to 5. Now, these are going to be out there. They do exist, but we got to be really careful not to just get in the habit of just putting this down. We got to be very sure that there are no number combinations that work. Let's look at problem D here. Looking at problem D, so this one has a 3 right here and a negative 14 there. Remember, those are going to be the numbers that go on top. And the way they go on top is because we have to multiply them. So 3 times negative 14, this is negative 42. We're going to have one m in the middle. That's going to go on the bottom. We're going to make our fractions on the side. This will be 3m and 3m. And now we're just looking for two numbers that multiply to give us negative 42, that add to give us 1. Now, the easiest way to find those numbers sometimes is to use a multiplication table. So if I insert a multiplication table here, remember you have one of these in our Schoology course, what we're doing is we're looking for all the 42s that show up on this list. So I do see a 42 that's happening right here. I see another 42 happening here, and another 42 happening here. Remember, most of our answers are going to come on this little arc. So, looking at our numbers, for our first 42, it was 14 and 3, and I don't think there's any way I can make 14 and 3 get us to be 1 on the bottom when I add it, so I don't think that's the one I need. And then it looks like I got another one that is 7 and 6. So let's try 7 and 6 for a second. So if I put 7 here and 6 here, now remember, we need to multiply to be a negative 42, which means either the 7 or the 6 is going to have to be negative. I'm going to put the negative on the 6 here because I think that will work for the bottom then. 7 times negative 6 is equal to negative 42. 7 plus negative 6 is equal to 1. So we found the two numbers that work. Now, before we write down our factors, we got to be sure that we go through and we simplify or reduce the fractions. This fraction, 3 and 7, cannot be reduced, but over on the other side, we know 3 goes into 3 once and 3 goes into 6 twice, so I can reduce that fraction, making my final answer into 3m, and since that's a positive 7, we're going to say 3m plus 7. And on the other side, we're going to have 1m minus 2. And this would be our final answer. Now let's talk about some special cases here for a second, because not every problem is going to be quite that easy. Now, it says most quadratic expressions are written in this form. What that form is that is ax squared plus bx plus c. And what we're going to notice is that there's always going to be a term that is squared, there's always going to be a just x term, and there's always going to be a constant term at the end that does not have an x attached to it. In order to factor, we kind of need all three of those parts. So if I look at problem A here, hopefully you notice that in the middle here, we're missing the just x term, right? There is no just x. We have an x squared term right here, but there is no just x term. And the reason for that is because we have 0 of them. So in this situation, in order to deal with this problem, what we can do is we could come over here and we could add in a 0x in the middle, just like so, right? Since we didn't have any, that's why we used the 0. And at that point, that actually fixes our problem for this problem. So coming over here, we would make our x again. Remember, the top number, the multiply number, comes from taking the number in front of the x squared and our constant term and multiplying them. 9 times negative 4 is negative 36. On the bottom, we're going to put 0. Then we want to make our fractions on the side. On the top of our fraction, we're going to have 9x over and 9x over. Now, we're looking for two numbers that multiply to give us negative 36, that add to give us 0. Now, we could go back to our multiplication chart if we want, and this time we would just be looking for the number 36. Now, I do see a 36 right here. I see another one right here. I see another one right here, and right here. So, the first one was 18 and 2. And I know there's no way I'm going to be able to make a 0 with those two. The next one is 9 and 4, and those aren't going to help me make a 0. But I do see this one, that is 6 times 6. Let's see if we can make that work. So if I put a 6 here and a 6 here, remember they need to multiply to be negative 36, so one of them needs to be negative. And actually I think I got it right there, because negative 6 times 6 is equal to negative 36. Negative 6 plus 6 equals 0. So we got it, right? And it's very important to remember we had to add in this term up top because that term originally was not there. Now before we wrap this problem up, we better be sure that we reduce our fractions. So coming over here, what goes into 9 and 6? Well, we know 3 goes into 9 3 times, and 3 goes into 6 twice. And that actually is the same simplification on the other side. Now this might be the first time that we've seen both fractions be reducible. And that is going to happen periodically. That is okay. So we always want to look for that reduction in the fractions. So this would be 3x minus 2 as one of our factors, and then 3x minus 2 as our other factor, which would make this our final answer. Let's go over to problem C. I know I'm doing these a little out of order. I wonder if you can tell me what's wrong with this one. Hopefully you're noticing that this one's a little bit out of order. So normally when we see a problem like this, our squared term is actually the one that happens first. So we're going to move that to the very front of the line. Now in the middle, remember, is our term that just has one of our variables. And at the very end is our term that has none of the variables. Now the reason why that's a plus 3 is because this was a positive 3, right? Remember, the sign goes with the number it's in front of. So when we come over here to factor, we would want to take 8 times 3. That's 24. That's going to go up on top. And then on the bottom, I'm going to have negative 10. On the side, when I make my fraction, I'm going to have 8k over and 8k over. Now we're looking for two numbers that multiply to give us a positive 24 that add to give us a negative 10. And I actually think I know this one without using my multiplication chart. I think this might be a negative 6 and a negative 4, because a negative times a negative would give us the positive, and a negative plus a negative would give us that negative 10. So I found the two numbers that work. Now before I go any further, remember, what you always need to make sure you do is you got to make sure that you reduce those fractions. So in this situation, when I reduce this, what goes into 8 and 6? Well, I know 2 does. 2 goes into 8 4 times. 2 goes into 6 3 times. And what goes into 8 and 4? Well, 4 does. 4 goes into 8 twice. 4 goes into 2 once. So my final factored form is going to be 4k minus 3 and 2k minus 1. And this would be our final answer. Now, for these last two problems here, these two get a little bit more difficult. There's actually a different method that we're going to use for these. And really the way you start to see this method is you start to see it by time. But one thing that becomes really important is that when we're trying to factor, if the bx term, the middle term, is the one that's missing, so if this is missing, we can add a 0x, right? And that's what we did over here, and that worked out just fine. But it turns out if one of the other two is missing, so if either this one is missing, let me use a different highlighter color. So if either the squared term is missing or the constant term is missing, so if missing, then we want to factor differently. So if missing, factor using GCF. And hopefully you know that greatest, or GCF, stands for greatest common factor. Now, looking at these problems, here's what I mean by that. In this one, we can see that the constant term at the end is missing. And since that's the one that's missing, that's the one that's going to tell us that we have to use kind of this new method. So what's the new method? How does it work? So first thing we want to do is we want to look at our terms. We have two terms here, 12x squared and 16x. And we want to figure out what those two terms have in common. Well, between 12 and 16, I know that 4 is the biggest number, the greatest number that I could divide out of those two. So we're going to pull a 4 out of those two numbers. Now, looking at our variables, this one has two x's and this one has 1. Since they both have an x in common, I can pull an x out. Now, when I do this greatest common factor factoring, then I want to add my parentheses here. And the last part of it is kind of a little bit of a unique step, but I say to myself, I say 4x times what gets me back to 12x squared. Well, I know if there was a 3 here, 4 times 3, that would get me the 12. And this thing had two x's. I know I'm going to get one x from here, so I must get another x from right here. And then I think to myself, I say, okay, 4x times what is going to get me to 16x? Well, I know if there was another 4 here, 4 times 4, right, 4 times 4 would equal the 16. And then this is already going to bring an x in when I multiply it. And I only needed one x, so I don't need anything else, which would make this our answer. Now, I know that's a little bit unique. We're going to keep practicing those as we go on a little bit further, but that's what we call factoring by using a greatest common factor. And I just want you to think what we did. We found, right, so we found our greatest common factor. That was the biggest thing we could pull out. So this was our biggest factor. And once we pulled that factor out, we said, okay, what would I need to multiply by to get back to what I started? What would I need to multiply by to get back to what I started? Let's take a look at another problem. Now, on this one, notice how we're missing the squared term. And the squared term is one of those important ones, right? This was the squared term that said, if it's missing, factor using the greatest common factor. So when we come over here, now is what we want to think, is we want to say, what's the biggest number that I can pull out of 40 that I can also pull out of 100? And at first, some of you might think 10, but I think there's one that's bigger. I think I could pull 20 out of both of those two numbers. Now, if I pulled 20 out of 40, right, so 20 times what would get me back to 40? That would be 2. And then 20 times what is equal to 100? Well, that would be 5. And then since I didn't pull out any m's this time, I know I would have an m still remaining right there. This is what we call greatest common factor factoring. This, again, is our GCF. That's the biggest thing that these two had in common. Now, why did I pull out the m? Because both of them did not have an m. Right? Only the second term had an m. That's different than when we looked at this problem over here, where they both had x's. Since they both had x's, we could take an x out. But if they don't both have x's, we can't. Let's look at one last problem. This one formatted really funny over here. That's okay. But when we look at it, what I want to sit there and connect on is kind of what's going on down here. Now, this problem is a little bit unique from the ones we've seen, and the reason for that is because 4, 10, and 6 are all divisible by the same number. Now, we're going to definitely spend more time on this problem. This is kind of an introductory one for us to see. But what number divides into 4, 10, and 6? And hopefully you're saying a 2 does. So we can use this greatest common factoring technique to pull 2 out of each of those two numbers, or 3 numbers. So if I pulled 2 out of the first term, that would leave us with 2x squared. If I pulled 2 out of the second term, that would leave us with 5x's. And if I pulled 2 out of the last term, that would leave us with just 3. Now, really important to get this part straight, that if I were to re-multiply these, I would just get back to my original. Now, at this point, what we're going to do is we're just going to focus on what's going on right here, and that's going to become our new factor piece. So, when I come over here and I try to factor this, remember, we want to sit there and take this number and multiply it by this number. So, I'm going to make my x, I'm going to have 2 times negative 3. That's going to give us a negative 6. The middle number is the number that goes on the bottom. On the side, I'm going to make my fractions. I'm going to end up with 4x on top and 4x on the top because, actually, pause. I'm going to have 2x on top because this is the part I'm trying to factor. We've already pulled that 2 out, so we changed the original. And we're just looking for two numbers that would multiply to give us a negative 6, that when I add them, they would give us a negative 5. And I think the number I'm looking for here would be a negative 6 and a positive 1. Negative 6 times positive 1 would equal negative 6. Negative 6 plus positive 1 would equal a negative 5. So before I go any further, we need that last step of reducing our fractions. So this would become a 1 and a 3. So I know my factors here would be 1x minus 3 and 2x plus 1. And then the very last step to this is, see that little 2 right here? We're going to drop that bad boy down in front just like that. Thank you guys so much for watching. Let's figure out what homework assignment you're going to be doing today. So if you go into your Unit 8 homework, we're going to be doing 8.1.3 today. The problems I want you to tackle, I want you to do 831, right? That's going to be the factoring part. You can skip part E, and it just says factor the following expressions if possible. And then the very last part, is there any other parts I want you to work on right now? Let's keep it really easy for you today. That's the only problem you need to do. So on 8.3.1, you just need to do 8-31. Please give that your best effort. This factoring stuff I know is difficult, but we're definitely still in the learning process of it. So if you're struggling with it, okay, that's okay. Embrace that productive struggle. Thank you guys for watching. Have a great day.